Okay, so the practice questions from yesterday were on this sheet. It says a second experimental design for building redox tables. Okay, so we're going to do what we were doing yesterday in the second method. We need to look at each equation to figure out which one's the oxidizing agent and which one's the reducing agent. So if we look at the CO2 positive, we see it's going to CO, which would have an oxidation number of 0. So it's gaining electrons, and if it's gaining electrons, it's being reduced. And if it's being reduced, it's the oxidizing agent. If we look at set in, it's a pure metal going to a metal compound, and so that means it's being oxidized, and if it's being oxidized, it's the reducing agent. Okay, and then we think of our spontaneity rule that says if it's spontaneous, which this one is because the products are written, then it means the half reaction oxidizing, for the oxidizing agent will be above the half reaction for the reducing agent. So over here, we would write CO2 positive aqueous plus 2 electrons going to CO solid. And then below it will be the set in one. And remember, the set in solid is your reducing agent, so it goes on this side. And over here will be set in 2 positive aqueous plus 2 electrons. Okay, and now we move to our next one, which is magnesium and zinc. And it says no evidence of reaction, which means it's not spontaneous. But if it were to react, it would be magnesium solid plus zinc 2 positive. So what's happening to the magnesium? It's gaining electrons, which means it's being reduced, which means it's the oxidizing agent. The zinc is losing electrons, going from a pure metal to a metal compound, a metal ion. So it's the reducing agent. So we think of our spontaneity rule again, and this time it's non-spontaneous, which means the Ra must be above the OA in the chart. So the Zn is already in the chart, so the Mg2 positive goes below it, so it goes down here. Mg2 positive aqueous plus 2 electrons going to Mg solid. Okay, and your chart is done. This will be the SOA, the strongest oxidizing agent. This will be the SRA, the weakest. Okay? All right, next one. In a school laboratory, 4 metals were combined with each of the 4 solutions. The evidence collected is represented by the following chemical equations. Construct a table of redox reactions. So we start with the first guy, which shows us beryllium and cadmium. And beryllium is a pure going to an ion, okay, which means it's being oxidized, which means it's the reducing agent. Cadmium 2 positive is going to 0, it's gaining electrons, which means it's being reduced, which means it's the oxidizing agent. Okay, and so then we think of our spontaneity rule. When it's spontaneous, which this is because the products are written here, the OA has to go above the RA. So we would write, and when you're doing this, you got to kind of be careful, right? You have to leave enough room at the top and on the bottom so that you can fill more in. So I'm starting about the middle here. I did there too because I knew there was just going to be one more. So CD2 positive, aqueous, plus 2 electrons going to CD solid. And then the beryllium goes below it, and remember the Be solid is your reducing agent, so it goes on this side, and over here will be Be2 positive, aqueous plus 2 electrons. Okay, now we go to the next one. Cadmium solid is going to cadmium 2 positive. Okay, so it's the opposite of above. It's now losing electrons, which means it's being oxidized, so it must be the reducing agent. H positive becoming pure hydrogen, it's gaining electrons, and if it's gaining electrons, then it's being reduced, which means it must be the oxidizing agent. Again, it's spontaneous, And in the spontaneity rule, the oxidizing agent goes above the reducing agent when it's spontaneous. So the 2H positive has to go above the CD, so it's going to be here. So 2H positive aqueous plus 2 electrons going to H2 gas. Okay, next one is copper and beryllium. So copper, I think that's copper. Can't really see. No, it's calcium. The one below it is copper. Okay, so calcium and beryllium. If there was a reaction, it would go to Ca solid and Be2 positive, aqueous. Okay, so the calcium will be gaining electrons, which means it's being reduced, which means it's the oxidizing agent. Beryllium going from a pure to an ion means it's being oxidized. It's the reducing agent. Okay, it's non-spontaneous because of the no evidence of reaction, which means the reducing agent has to be above the oxidizing agent. The beryllium is going to be above the calcium in the chart, which means the calcium goes down below it. So Ca2 positive aqueous plus 2 electrons going to Ca solid. All right, the last one. This one's copper. Copper solid, it would be going to Cu2 positive if it was reacting in H2 gas. Okay, so copper, pure copper going to an ion means it's losing electrons, being oxidized. It's the reducing agent. Whereas the H positive is going to pure hydrogen, so it's gaining electrons, which means it's being reduced, so it's the oxidizing agent. No evidence of reaction means the reducing agent is above the oxidizing agent, so the copper half reaction has to go above the hydrogen one in your chart. Remember, the Cu solid is the reducing agent. It goes over here. The Cu2 positive aqueous will be on the reactant side. Okay, and we're done. SOA is up here. SRA is down here, and they go up. All right, next, number 3. Says, using the relative strengths, and then you do the same thing. All right, so we have, now you have to look here. Both, like, silver is going to be a positive 1. We're doing now the oxidation numbers. And this will be a negative 1 because the overall is 0. And if you look in the chart, you'll see that the Br is in the negative 1 spot. Okay, so going from 0 to positive 1, right? Because this is a solid, a pure to a positive 1, it means it's losing electrons. And if it's losing electrons, it's being oxidized, which means it's a reducing agent. Whereas bromine is going from 0 to negative 1, which means it's gaining electrons, which means it's being reduced, which means it's the oxidizing agent. Okay? It's happening, it's spontaneous because the products are written, which means the oxidizing has to go above the reducing. And so the bromine liquid, whoops, I lost the R though, and there's a 2 there, plus 2 electrons will go to 2Br negative aqueous, right? Because bromine is diatomic. And then silver goes below it. So Ag positive aqueous plus 1 electron going to Ag solid. Now you might be saying, how come I put 2 electrons there? Because this is Br2. And so you have to have 2 Br negatives on this side, which means you need 2 electrons to balance it, or else the charge won't balance. Okay, the next one, and this one was probably the toughest one because of the Br2 and the I2. So in this one, again, silver would be 0, and if it was reacting, it would be going to silver positive 1 over here. And the I would be going to 2I negative, okay? So again, if you look, it's going to positive 1, so it's